Good morning everyone. We are group 10 from the 6th semester of the Department of Electronics and Communication Engineering at Coachbihar Government Engineering College. Today we are excited to present our mini project titled Temperature Activated Alarm System. This project is a practical implementation of real-time monitoring and embedded system design aimed at addressing critical needs in safety and automation. Our team members are Bappa Saha, Rupam Ghosh, Sayem Anshari, Ashish Biswas, Srijita Kundu and Nabadipta Roy. I am Bappa Saha. I am presenting the first part of this mini project presentation. Our project is called Temperature Activated Alarm System. The main objective of the system is continuously monitoring ambient temperature using a digital sensor and to trigger an audible alarm if the temperature exceeds a user-defined safety threshold. In simple terms, the system is designed to alert users in case of potential overheating or abnormal environmental conditions. It's an efficient and cost-effective solution for safety-critical applications. This is an overview of how the system works. Our system is ideal for places where maintaining a stable temperature is very important, such as server rooms, greenhouses, industrial storage units, or even in homes for safety. It uses a DHT11 sensor to measure temperature and humidity and an ESP32 microcontroller to process the data. When the temperature goes above the defined limit, a buzzer is activated to alert the user. There is also a push button provided to manually silence the alarm when needed. In short, the system is smart, compact, and power efficient, perfect for continuous temperature monitoring. Here are some key features of our system. Real-time temperature monitoring, customizable threshold, audible alert using a buzzer, manual alarm reset with a push button, compact and energy efficient design. This system has a wide range of applications such as preventing overheating in electronics, supporting agriculture in greenhouses, enhancing fire safety at homes or offices, monitoring baby or elderly rooms for temperature stability. Its flexibility makes it suitable for both personal and industrial use. Now the next part will be continued by our next member.
Now, let us study the different components required to make the temperature activated alarm system. At the center is the ESP32 microcontroller, which functions as the brain of the system. It continuously reads temperature data from the DHT11 sensor, a digital sensor capable of measuring both temperature and humidity. When the sensed temperature exceeds a present threshold, the microcontroller activates a buzzer to provide an audible warning. The buzzer is directly controlled by one of the ESP32's GPIO pins, making the circuit simple and efficient. A push button is included to allow the user to manually silence the alarm after it is triggered. The entire system is powered by a 5-volt supply with onboard voltage regulation to provide the necessary 3.3 volt for ESP32's operation. This setup is reliable, compact, and energy efficient, making it suitable for applications such as room temperature monitoring, equipment protection, and early fire detection in homes, laboratories, and small industrial environments. The next part will be continued by our next team member.
Now I will explain the operation mechanism, circuit and the flowchart of our temperature activated alarm system. Operation mechanism. Our system uses a DHT11 sensor to detect temperature changes. It sends digital data to the ASP32 which processes in real time. If the temperature exceeds a limit threshold, the ESP32 immediately activates a buzzer to alert the user. To give user control, a push button is added. It allows manual silencing of the buzzer after the alarm is triggered, avoiding continuous noise. Circuit diagram. The circuit diagram, we used an ESP32 DHT11 sensor, a buzzer, and a push button. The sensor connects to the ESP32's GPIO4 pin while the buzzer is powered. The push button is also connected to ESP32, allowing user input to stop the buzzer. Now the flowchart. This flowchart shows how the system works step by step. It starts with the ESP32 reading the temperature. If the reading is below the limit, it keeps monitoring. If the temperature goes above the threshold, the buzzer turns on. The system keeps the buzzer on until the push button is pressed, and which reset the alarm and resumes normal monitoring. So this is how the system ensures real-time temperature tracking with immediate alerts and manual control.
Hello everyone, I am Sayem Anshari. Today I want to talk about the temperature activated alarm system results. The results are divided into four parts. First part is successful temperature detection. The DST of temperature sensor continuously monitor ambient temperature with the operational range 0 degrees Celsius to 50 degrees Celsius. The reading were found to be reasonable accurate with average fluctuation of plus minus 1 degree Celsius. Temperature values were continuously displayed on the serial monitor. Second parts are threshold-based alarm activation, where ambient temperature crossed the predefined threshold temperature. Suppose the threshold temperature is 30 degrees Celsius, ESP32 microcontroller immediately triggered as buzzer via a MOSFET switch IRFZ44N. The push button circuit effectively allow manual detective of the buzzer simultaneously a basic user acknowledgement or reset function. This setup validation system use wiring mechanism for overshooting environments. Third part is system stability. The system run in a continuously monitoring loop over extended duration without the crossing or hanging. The power supply was stable and sensor data was processed reliable without the interrupt or major draft. This confirm the system suitability for continuously used environments like server rooms or greenhouse. Fourth part is power efficiency. The circuit operates on 3.3 volt to 5 volt, consuming minimal current under normal conditions. The buzzer and IRFZ44 switch ensure that the power was only consumed during alarm activation, making the system energy efficient and suitable for battery-based setup. And the remaining part will be say our next team member.
Let's now discuss some observations and learnings. The DHT11 sensor, while not highly precise, is suitable for general monitoring tasks with its 2 degrees Celsius accuracy. The ESP32 handles data acquisition and processing with zero lag, proving its efficiency. In future versions, we can use the ESP32's Wi-Fi feature for IoT-based temperature alerts. The system shows strong use case potential in home, server rooms, agriculture, and medical storage units. Overall, the project achieved its goals of building a smart, reliable, and cost-effective temperature alert. The next part will be discussed by our next member.
Now that we have seen how the system works, let's take a look at some of its practical application in the real world. This temperature activated alarm system is highly versatile and can be applied in many critical areas. For instance, in homes and offices, it can serve as basic fire detection system by triggering an alert when the room temperature rises than usual. These can act as a supplement to traditional smoke detectors. In industrial environments, it can monitor machines or electrical panel for sign of overheating, thus preventing costly damages or even fires. For medical and food storage, when maintaining a specific temperature range is critical, such as a cold chain for vaccines or goods. This system can offer real-time alert when conditions deviate from the safe range. In agriculture, particularly in greenhouses, it helps maintain optimal growing conditions by alerting farmers to sudden temperature shifts, ensuring crop safety. Other potential areas including automobile safety, where it can alert drivers about engine overheating and warehouse storing chemicals that requires regulated environment. These uses highlights the system adaptability and its relevance in both safety critical and convenience focused applications. In conclusion of our mini project demonstrated how a simple yet smart embedded system can contribute meaningfully to safety and automation in various domains. By integrating affordable components like the ESP32, DHT11 and a buzzer, we have created a real-time temperature monitoring system that is both efficient and easy to deploy. Its modular design also opens door for future enhancements such as IoT connectivity and mobile notifications. We are grateful to our faculties and institution for their support and we sincerely thank everyone for your attention. We hope this presentation gave you valuable insight into our work. Thank you.